Section 1.6. Transformations of graphs. Okay, so basically we want to try to do as much of this without using technology as we can. We're going to look at how can we, so our goal for this section is, can we just sketch quickly like this right here? Let's just say it's y equal negative x plus 2 cubed minus 4. Okay, that's our goal. It's just to sketch that. So basically there's two categories. I mean, that's an example of one of the graphs. There's two categories that we're going to look at. The first thing we're going to look at are what are rigid transformations. And then we're going to look at non-rigid transformations. Okay. So we'll start with the rigid transformations first, but before I get going, there should be certain graphs that we kind of know their basic shape without having to plot a whole lot of points. So, and I'm going to call all of them f of x, but we'll see. I'll explain later why I'm calling them all f of x. So let's just start with x. The graph of x, what does it look like? Or y equals x. Yes, so if you just want to finger draw, so it's a line that goes through the origin, slope is 1, all right? Then you have x squared. So what's the graph of x squared look like? All right, parabola. Vertex is at the origin. All right, x cubed. What does that graph look like? So it's kind of like a squiggle shape, right? Like this. Now, if you don't believe us on any of these, other than using your calculator, how can you go and get the shape? What could you do? Plot points, that's exactly right. Anytime you're dealing with graphing and you want to know what a graph looks like, it always goes back to plotting points. Okay. Square root of x, what does that look like? Okay. Just the top half of a parabola that opens to the right. All right. Running out a little room here. What about cube root of x? Do you know what this looks like?
Would it be like that one that just turned on the slide?
It's similar to this. Let's do this. Let's generate some points real quick. So cube root, you know what cube root means, right? What does cube root ask? When you plug in something into cube root, what does it ask? So it would be good to pick perfect cubes as your x's. So what I would start with is is 0 okay? Can you do the cube root of 0? What's 0 times 0 times 0? 0, okay. Can you do 1? But I don't want to plug in a 2. Why don't I want to plug in a 2? Yeah. What would be the next number you might want to plug in? An 8. And then you can also plug in negatives, -1 and -8. So plug those in and get the points real quick, and we'll look at what the graph does. You can, or can you do the cube root of a negative? Yes, you can, because you have to, because cube root of a negative, you should get a negative, because it's asking what number multiplies by itself. So get those outputs real quick, and now you have the answer to your question. Now you should be able to get the shape. So what did you get for cube root of -8? Cube root of -1. Cube root of 0. Cube root of 1. Cube root of 8. So if you look at this, 1, 1 is here, 8, 2 is there, -1, -1 is here, -8, -2 is there. So what's the answer to the question? What does it look like? Yeah, that's a good answer. It is like x cubed, it's kind of flipped there. It's also similar to square root of x, but then also in the third quadrant like that. See, that looks similar, okay? One more graph, I think. What's the one more basic graph you could think of? Yeah, absolutely. I think that's the last one. So what am I doing, other than this picture here, what do you call when you just make a rough plot, you don't really spend a lot of time, you're just putting a picture there real quick, what do you call that? So I would say this is not a plot. I'm really only plotting one point on all these. See, I've only plotted one point. What's the one point I've plotted? The origin. Here, this is a plot, because I plotted 5 points, okay? But the other ones are just called sketches. They're a sketch. So I'm going to teach you how to sketch a graph quickly. Notice that's what my question was here. Can you sketch this? See? Can we sketch that? And I'll call them all f of x for a reason. And we'll come back to that. Okay. So those are your 6 basic graphs. There could be more. We might add to it. We may go in and say, hey, let's see what this basic graph is. And so from here on out, I'm not going to plot all these points for cube root. I'll just plot the origin and draw that little squiggle shape. But you're right, it is a reflection of this. You know what this graph is reflected about to get this. If I put them on the same picture, it might help. Yes, the line y equals to x. Those have a relationship. So if you put the x cubed and cube root of x on the same, let's say, all right. So what I'm going to do now, you have those, I would store those in your notes. We'll come back to those pictures when we need them. So now let's look at what I mean by a rigid transformation. So what I want us to do is, what would happen if we wanted to take our x squared graph and we put a +2 on the end? What happens to the graph? So this one you probably already know the answer to. And I want to see if you can tell me why it does that. So what is going to happen? So first question, we'll just call this example 1. Could we sketch this one quickly? How and why? Well, how do you sketch it, and why did you do what you did? Anybody wants to take a crack at that answer? Yes, ma'am.
It's like a U, what you move up to, just because of the parabola.
Yeah, it's the same. So we all know the basic parabola shape, right? You got your basic parabola. She says you move up to. So how do you graph it? Like this. If I translate what she said, that's what she said. What did she not answer? The y. Can you tell me why you did that?
Because you have to move on the y because you're not adding just x to the 2, you're adding everything together to it. That made no sense.
No, it was actually making sense. You just gave up on yourself. I thought it was pretty good.
Oh, really?
Yeah, I was following you.
So since you're not, it would be, if you're moving the x, it would be x plus 2 parentheses to the square, but since it's not in the parentheses with the x.
You were saying you're adding 2 to the everything, when you're saying to everything is that. And what does that do? What does this do?
X is left and right,
Okay.
but all of it together, like without just including.
Forget about the 2. What did that do before? That right there gave you your what? Your y's. That's what y equals. Y is x squared. That's how you get your y's. You square x to get your y's. So if we just did this, notice if I just plotted this one, what would be good x's to plug in just to plot x squared? What would you pick? If you want to plot x squared, you want to really put a plot, what would you pick for your x's? That's exactly what I would pick. Negative 2, negative 1, 0, 1, 2. And I would plug those in. You would get 4, 1, 0, 1, 4. Okay? Notice this is what gives you your y's. Square your x to get your y's. The x squared is how you generate your y's. So if I did go and draw that picture, right, negative 2, 4, negative 1, 1, 0, 0, 1, 1, 2, 4, I have that picture right there, which is what we said it looks like. Now, what I wanted you to see is from your explanation, when I like how you said you add 2 to everything, to this. This is what gave you your y in the first place. See, so now if I keep the same x's that we used before, it's going to be negative 2 squared plus 2. So you're going to get 4 plus 2. It's going to be negative 1 squared plus 2. So you're going to get 1 plus 2. 0 squared plus 2. So you get 0 plus 2. The 4, the 1, and the 0 were all the y's from here. And you're adding 2 to them. You're adding it to the y. That's exactly, you're adding it to the original y's. So what's happened is the 2 is being applied to y's, not to x's. Like she was saying, when you start to work in with the x, then you're changing it horizontally. Here's why, and here's the thing. So here's our graph. So I'll put our graph in pink here so you can see it. So this is our graph. So every point you have should move up 2. 0, 0 should be up to 0, 2. 1, 1 should be up to 1, 3. 2, 4 should be up to 2, what? Where should that point be? 2 what? 2, 6. Okay. But we're trying to do a plot or a sketch. What are we trying to do? A sketch. Everything I'm trying to do is teach you how to quickly get the pictures without having to plug it all in. So rather than keep making T-charts and doing that over and over again, if I gave you this and I said sketch, what are you going to do?
Or up on the y, positive y-axis.
You should do the same thing you just did. It's that. Look, if I cover that up, is that a basic graph? What did we notice when we put a plus 2 at the end? The whole graph moved where? Why did it move up 2? You added 2's to the y's. That's exactly right. This is what gives you your y's, the 4. Right? That's one of your basic graphs. So nothing changes. I'm doing the same thing. Okay? So now replace it. Notice I called every basic graph f of x. At the start, I said f of x is x squared, and it looks like this. F of x is absolute value of x, and it looks like this. So I did that on purpose, because now if I take that out, the point is not to work for each individual graph. What happens all the time? Well, this is the form. If it's a basic graph plus 2, it's always going to move where? Up 2. So I just took your basic formula out and put that in place. That way now it works for any graph, as long as you know the basic picture, because you're basically adding 2 to your function, which gives you your y's. Well, all right, so if I gave you this, x cubed minus 4, what should happen? You take the x cubed graph and you should move down 4. Again, another way to do it is, instead of making the whole T-chart, you know the one key point is 0, 0. Well, if I do x cubed minus 4, if I look at that key point, 0, 0 cubed minus 4, you get what? Negative 4, which kind of helps me feel better about it. So now if I'm going to graph this one, I take my x cubed graph and I move down 4 like that. Okay? And it fits the form f of x minus 4, which means we're subtracting 4 from all of our y's. So I thought your explanation was good. I would just, the only word I would have said from everything from the y's, because that's how you get your y's. And this is how you get, we call this vertical shift. All right, so now I'm going to make a little formula. Can I erase the board there? I know I'm kind of running out of room and I just started. So now, let's just assume our constants are greater than 0. So if we, how do we know we have a vertical shift? So vertical shift. If we have y equals f of x plus c. So the c is on the outside, and let me just assume that c is greater than 0 for now. Okay, c itself is greater than 0. Where do you move? You're going to move where? So if it's plus c here, we move where? Move, where we say shift, f of x where? Up, how far? C units. Okay? And if it's y equals f of x minus c, so now if c is greater than 0, but I do minus, so if I do minus 4, where are you going to move? Down, because it's a minus. Okay? Down. So you're going to shift f of x down c units. All you got to do is know f of x. Okay? And that's your vertical shift. All right. Make sense? Let's just stick with our, actually, let's do square root this time. So let's just make a basic, the t-chart for square root of x. What would you pick for your x's for square root of x? Kind of like on cube root of x, we had to be smart about what we picked. What would you pick for your x's for square root of x? I would be more specific than that. Perfect squares. Positive perfect squares. So what would be the first 4? 0, 1, 4, 9. So square root of 0 is 0. Square root of 1 is 1. Square root of 4 is 2. Square root of 9 is 3. And we should have the picture that we talked about earlier. 0, 0 is here. 1, 1 is here. 4, 2 is here. There's a picture. Okay. Ready? How do you sketch square root of x minus 2? So now I've done what? Where did I put the 2? In with the x. It directly affects the x, which now directly affects your outputs. So once you plug in an x, you're doing what immediately to it? Subtracting 2. So my question is, how would you sketch that?
Well, x is like flipped, so it's like you have to move it to the right, even though you think you move it to the left, right?
She said you have to move it to the right, even though you think you would move it to the left.
Like, yeah, because it's flipped for some reason.
That's why I picked this one on purpose. Because now you need to pick, so now here's what I want you to do. I want you to make a t-chart for this. And I only want you to pick x's that give you positive perfect squares under here. Because, right, you can't have a negative under the house, can you? Right, if you have a negative, then you have imaginary number. So pick only x's that give you positive perfect squares. So you're trying to get a 0 under the house, a 1 under the house, a 4 under the house, and a 9 under the house. What do you need to pick to get those under the house? Go. Figure it out. And that will answer your question. For me, this is the best way to explain it. I think it helps with this picture because you know you don't want a negative under there. Okay? So Michael, what did you pick to get a 0 under the house? 2. So you didn't pick 0, you picked 2. It gives you 2 minus 2, which is square root of 0, which is 0. So now you don't have the point 0, 0, you have the point 2, 0. You really could stop there. That shows you. All right. Miles, what did you pick to get a 1 under the house? A 3. What did you pick to get a 4 under the house? Anybody? 6. So now if you're comparing, look at the original x's, and now look at these x's. They are how much? 2 bigger. And they have to be 2 bigger to get the same y's because what's happening as soon as I plug them in? Subtracting 2, that's exactly right. So here we go, 2, 0, 3, 1, 6, 2. And of course, the last one would have been what? I didn't plot it, but what would it be? All right, so is this method that I'm using fast or slow? Too slow. That's why we just know what happens, right? So let's just go back to our parabola real quick. So had I put a minus 2 in with the parabola, I like to always say, look, just think about that origin. What happens to the origin point? So we know on x squared, we have the point 0, 0. It looks like this. So if I go to plot this, notice the minus 2 is in with the x, just like it was on the square root. What should happen to this graph?
Right.
The exact same thing. So think about this point, 0, 0. You plug a 0 in to get y is 0. My question is now, what do you got to plug in so that y is 0? A 2. That helps, I think. 2, 0. Where did that point go? The origin was here. Now it's here. You're going to have that picture. And then the same thing now, so if a minus on the inside makes it move right, then what would a plus do? So if I wanted you to do, sorry, I'm running out of room. If I wanted you to graph this, what would that look like?
Squiggly through -2.
Squiggly through -2. Because think -2 is now is going to give you 0. It's going to go like that. Okay? Everybody with me on that? How can we generalize this? So how can I say for any graph, so instead of just, because this is specific, left 2 for the x cubed, or this is specific. How can I do it for any, like what would the notation need to be that for any graph it goes left 2? So instead of plugging in, notice I used f of x for all of my basic graphs. What can I write to say left 2 for all the basic graphs? Very good. Or we'll just do the plus 2 for now. F of x plus 2. That means take your basic graph and move left 2. Right? This is how you write it for, because you may have a made up function that you don't know the equation for. So like you might have a function like this. Your function could just be like a check mark looking thing or something. You could say, here's your function. And it goes like this. Right? And I want you to do that. What should that tell you to do? Move to the left 2. That's exactly right, because it's in with the x. So that means shift left 2. All right, what does this mean? Very good, down 3. Because the minus 3 is on the outside. What does this mean? There you go. So to write horizontal movement, we put it into parentheses. So exactly what Elgin said there. So if I want to show a horizontal shift, if we do y equals f of x minus c, that's right c units. And if we do y equals f of x plus c, that's left c units. Okay. All right. So now you should be able to do two transformations in one. I think this is example 2, I don't know. Let's do sketch, not sketchy. Sketch, y equals absolute value of x minus 4 minus 5. So can you sketch that one with those two transformations? Go ahead, real quick. So a sketch is, how many points should you plot? 1. Move the origin to wherever it goes, and then plot that. Okay, so Lily, how did you move it?
Right 4, down 5.
All right, what's the basic graph, first of all? The V. So it looks like this, whoops. It looks like this, right? That's the basic graph. That's your right 4, and that's your down 5. And so you went 1, 2, 3, 4, 1, 2, 3, 4, 5. So at 4, negative 5, that's where the origin moves. Now, of course, I'm not showing what the x and y intercepts are properly, but it's okay. You can. That's a good enough for the sketch, okay? Because we're just trying to sketch. So far, everything I'm showing you is called a rigid transformation. Rigid means that the actual shape of the graph isn't changing, it's just its location is changing. So the shape is staying firm. The next lesson, we'll look at the non-rigid. That's the next one. I want to just get to this. All right, 2 more transformations, okay? All right. What would your t-chart for absolute value of x look like if you were going to do a t-chart? Miles, what would you pick for your x's? I'm picking you on purpose because you gave me the perfect answer before. We were like robots when I was a kid. We actually had a TI-80. And we could graph, so I'm not going to tell you we didn't have them, but we didn't use the calculators very often. Then we got TI-81. Okay? So what are you going to get? When you plug these answers in, what's going to happen each time? It's going to come out positive except for which one? 0. So I wouldn't say different sign, right? Because you got to be careful about that because the sign stays the same. You get 2, 1, 0, 1, 2, and you got your picture. All right? I'm picking this one on purpose because here's the one I want you to plot now. A negative is on the outside of the function. So again, let me ask this question. What does this give you? This right here, or inside of my hand, gives you what? Your y's. It is the function that gives you your y's, right? That's how you got your y's before. You did absolute value of x. That's what gives you your y's. Now I'm putting a negative in front. Now what happens? So go ahead and do this t-chart real quick. See what you get. So what should you do first, the negative or the absolute value? Absolute value, because of order of operations. Do that first. Okay, so what happens? Negative absolute value of -2. So if we do absolute value of -2, we get 2, and then there's a minus in front. So now, as before, all of our answers came out positive. Now all of our answers are coming out except for the 0. Yeah, well, negative times 0 is still 0. So all of our y's are opposite, right? So now it was -2 is here. -1, -1, 1, -1, 2, -2. So it does this.
So flipping.
It's flipping or reflecting about the x-axis. I like to call it rotisserie chicken. Like a chicken rotating like that. Okay? So how do we know that's going to happen? What's the indicator? The negative is located where? In front. So anytime you have negative in front, it's going to flip about the x-axis because we are negating y values. We're negating y values. So, question, what would this graph, what would that look like? So I would always start with the basic picture. All right, this is a negative in front of the cube root. So first question is, what does cube root of x look like? Good, just finger it. So anytime you just air drawing, that gives me quick feedback. So here's cube root of x. Now, I'm going to point to the point. You're going to tell me what's going to happen to it. It stays the same. Where's this one going to go? It's going to go up and become positive. So if you just kind of want to imagine, it's going to go there. And then where is this point going to go? Down. And now you should be able to get the picture. So we're reflecting or flipping about the x-axis. So if we want to draw this, I'm going to draw it in hot pink. It's going to go like that. And then I can, since I have a whiteboard, I can get rid of the basic graph. You have paper and pencil, so maybe you draw the basic graph real light and then draw your final graph dark. Okay, does that help visualize that one? Okay, so how would we write this? Oh, I already did, sorry. So like this. That's the general way for any graph if you have a negative in front. Flips it. Okay, is this still a rigid transformation? Have I changed the shape of the graph? No, I've just changed where it's at. I've just flipped it. If it was made out of like wood, I haven't changed the shape. I'm just rotating it, okay? So I guess I'll put this here. I'm running out of room. So we have one last flip, okay? So what's the last flip that I haven't shown?
X.
Yes, very good. So again, just because I think it highlights better, let me use square root of x again. So 0.149 is what we used before. We got 0, 1, 2, 3. So my question is, a negative in with the x, what happens? So what do you think it's going to do? So a negative in front flipped about the x, what do you think a negative on the inside is going to do? Well, I thought you can't take the square root of a negative. Am I even able to do this? Yes, I am. Yes, you can, and you will get a graph. I picked this one on purpose. So what did we just say? You cannot take the square root of a negative, correct? You won't. Because who's in charge of picking the x's? You are. So pick the x's so you don't take the square root of a negative, and then it's going to show you exactly what the graph is. So you make a t-chart for this. Pick x's so you never get a negative in here. Try to get what? But what do you want on the inside? What do you want on the inside of the house? Positive perfect squares. So pick the x's so that you have positive perfect squares on the inside of the house. Go ahead. And you can have a 0.
up, boss?
Leave it open. Again, I have my reason why I pick certain ones. Okay? So we want square root of 0, square root of 1, square root of 4, square root of 9. That's what we want, so you've got to think about the x's you pick. Courtney, can you give us your x's? So the square root of 0 is easy, right? What do you pick for square root of 0? 0. I've still got that one. Because even though you're going to multiply by a negative, it's negative times 0 is still 0, we get that one. But what do you pick so that we get a positive 1 in here? A negative 1. What do you pick for a positive 4? Negative 4 and negative 9. So I picked these on purpose because I think it highlights the transformation much better. So you get square root of 1, square root of 4, square root of 9. So by picking negative x's, so let's look at this picture. Here's the original picture. It goes like this: 0, 0, 1, 1. I'm just going to do 4, 2, and stop. So now if I pick these 0, 0's here, negative 1, 1, negative 4, 2, there's the picture. So how does it flip, or how does it reflect? About the y-axis, right? Now, I picked this one on purpose. Is it possible to flip about the y-axis and not see a change? Yes. Can you give me an example? Very good. Because the absolute value graph, so if you have this, you're not going to see anything. If you flip it about the y-axis, you get the same thing. And absolute value of negative x is the same as absolute value of x. You get the same answer. So you won't see a change. How do I write it generally, Elgin? How do we write a negative on the inside for any function? What would be my little formula? Y equals what? Yeah, f of negative x. That's exactly right. So anytime we have this look here, we will say flip f of x about the y-axis. So if the negative on the outside is rotisserie chicken, what do you think I call this one? What flips like this? I call it a person in a sport. Kind of. Yeah, I could do it here. I'll try to do it in front of the camera. So here, I'll try to mimic this here. This is a person here that doing like this. Yes. There you go, and like that. Okay? Ice skater. That's why I call this one. There's my triple axle. I didn't tear it. Isn't that what they call it? I don't watch it. So. All right. So anyways, there's your ice skater. Flip it. Now, that is all your non-rigid transformations. I'm sorry, rigid transformations, not non-rigid. We're going to do that next lesson, next time. So what I've left off is if you have a multiplier. When you start multiplying by a number, it changes things. If you have any in the homework, just kind of, well, I have to generate the homework because it's something's wrong. So I got to fix that. But so right now you've got all four of the rigid transformations. So now let's look at our goal. Our goal today was to sketch this. When I do my sketches, I go in this order. I always work left to right, and I do my flips before I do any horizontal or vertical movement. So flip it first, then do your movements, and now you should have the sketch of that. Once you flip it, leave it. So flip first, then do your horizontal and vertical movement. So first, do any reflections or flips. Then the second thing I do is horizontal shift, if I have it. And then the next is vertical shift. There actually is a 1.5 in there, right? I have to do in here, this step is your stretches if you have them, stretch or smash. So that we're skipping because I haven't done a stretch or smash yet. So you'll know when we have a stretch or smash. I'll show you that. We're just breaking up the lesson. So real quick, you should have this picture. So here's our goal today. What should I always start with? What do I gotta have memorized? Yeah, basic shape. So once I see a cube, my memory goes and takes me to the x cube. Where is this negative located? On the inside or in front? So how does it flip? Across the x-axis. A negative in front negates the y's, flips it about the x. So this piece goes where? Up, and this piece goes down. Now it has the same look as if the negative had been on the inside. That's because this is an odd function. So an odd function will always do it. So there's that. Then from there, I just move that dot. Where does that dot move? Left 2, where else? Down 4. And there's your picture. Okay, that's it. Those are your rigid transformations. Okay. All right, so that'll get you started on 1/6. The next lesson will be on the non-rigid, which is if I have a multiplier, and we'll look at that. All right, so I'm gonna stop because that's 41 minutes.